Good morning, dear students. Today we will start our new chapter, that is the solid state. It is your first chapter of NCERT textbook. Now in this chapter, the first topic is the classification of solids. So before we start the classification of solids, let us talk about liquids, gases and solids together. We know it very well that liquids and gases have the ability to flow. They can take the shape of the containers. As liquids and gases can flow, so this state belongs to fluid state. While we know it very well that solids do not flow, they are rigid. They cannot take the shape of the container. So solids are also called non-fluid state. Now move to solids. So here first we have the classification of solids into two types. First one is crystalline solids and second one is called your amorphous solids. Crystalline solids are having orderly arrangement of the particles. These particles can be atoms, these particles can be ions, these particles can be molecules. So if solids are having orderly arrangement of the particles, then the solids are called crystalline solids. They are also called true solids because they have orderly arrangement of the particles. Due to orderly arrangement of the particles, they are having a characteristic geometrical shape. Due to orderly arrangement of the particles, crystalline solids are having characteristic geometrical shape. Examples are sugar and salt. Remember, these solids have sharp melting point. Means, if the melting point is achieved, then the whole solid will be converted into liquid state. So it is about crystalline solids. Now second part is your amorphous solids. As the name suggests, amorph, no form. Particles here are randomly arranged. They don't have a well-set arrangement, well-set pattern for the arrangement of the particles. And that's why they are also called pseudosolids or supercooled liquids. Examples are plastic, rubber, etc. They don't have characteristic geometrical shape. And if we talk about their melting point, they have a certain range. In which range the solids gets melt. So here they don't have sharp melting points, they have a range where the solid state will be converted to liquid state. Now in this chapter, we will completely talk about the crystalline solids because they are the true solids. Now if we talk about crystalline solids, then there is the classification of crystalline solids also. And the basis of classification is the nature of interparticle force and the constituent particles present in the given solid. So crystalline solids are further classified into four types. First one is your molecular solids, second one is your ionic solids, third one is your metallic solids, and fourth one is your covalent or network solids. Now about molecular solids. Here in molecular solids, the constituent particles are molecules or repeating units of molecule is there. Suppose if we talk about ice, H2O solid. Then in ice, we are having repetition of H2O molecules. Because molecules are converted into solids, that's why it is called molecular solids, where we can say molecules are the constituent particles. Now it is further classified into three types. First one is your non-polar molecular solids, second one is your polar molecular solids, and third one is your hydrogen bonded molecular solids. Now when we talk about non-polar molecular solids, then remember, non-polar molecules will be involved in the formation of the solids. Means, if the same type of atoms are forming the molecule, and these molecules on application of pressure gets converted to solid, then these are called non-polar molecular solids. Remember, between the non-polar molecules, weak dispersion force or van der Waals force of attraction is there between the molecules present in the solid. Example here is H2, Cl2, I2. All these are non-polar molecules. Then we have polar molecular solids. Again, the constituent particles will be molecules and the nature of molecules will be polar molecules. When different atoms are involved in molecule formation and these molecules gets converted to solids on application of pressure or development of force, then the solids formed are called polar molecular solids. Remember, dipole-dipole interaction between the molecules is the force present when the molecules gets converted to solids. Example is your solid sulfur dioxide. Then we have hydrogen bonded molecular solids. Here also molecules will form the constituent particles. But here one important condition is there. Between the molecules we are having hydrogen bonding. We know it very well that when hydrogen atom comes in between the electronegative elements like fluorine, oxygen, nitrogen, then there is a development of intermolecular force of attraction which is called hydrogen bond. So if polar molecules are forming hydrogen bonding and gets converted to solid, then such solids are called hydrogen bonded molecular solids. Example is H2O solid which is called ice. H2O solid which is called ice. Remember, these are insulators. These are insulators. They do not show electrical conductivity because the current carrier particles are absent. There are no ions. There are no free electrons. And if we talk about their melting point, then they have low values for the melting point. Then the next one is your ionic solids. As the name suggests, ionic solids. Ions will be the constituent particles. So whenever a force of attraction is there between the different ions, opposite ions, and we know it very well that between different ions we are having electrostatic force of attraction. So here the constituent particles are ions, and between the different ions, opposite ions, the force of attraction is electrostatic force of attraction. The solids are called ionic solids. Example NaCl, KF, etc., etc. So whenever metals are involved with non-metals in the formation of the molecule, or when bonds are formed between metals and non-metals, we always get ionic solids. Remember, ionic solids are poor conductor of electricity in solid state because ions are not mobile. Ions cannot change their position in solid state. But in fused state or molten state and aqueous state, ions are free to move. So in fused state or molten state and aqueous state, they show electrical conductivity, means they are good conductor of electricity in fused or molten state and aqueous state also. If we talk about their melting point, between opposite ions we are having a strong force of attraction, that is electrostatic force of attraction. So they have high value for the melting points. Then the next one about the metallic solids. Whenever metallic atoms are involved, then the case will be of metallic solids. What about the particles? What about the arrangement? Metals are orderly collection of positive ions surrounded by and held together by a sea of free electrons. All the metallic atoms are losing their valence electrons and gets converted to positive core, which is called candle. And the electron lost from the metallic atoms, forming clouds of electron, which is called sea of electron. So here, metals are orderly collection of positive ions surrounded by and held together by a sea of free electrons. Example, all the metals. They are good conductor of electricity because they have presence of free electrons. Whenever potential difference is applied, the free electrons shows movement, can change their position. If we talk about their melting points, then they have high value for the melting points. And the last one is your covalent or network solids. Why this name is their network solid? Because here in this type of solid, the constituent particles are the atoms. Between the different atoms, we are having strong chemical bonds. And these atoms on repetition, forming a giant molecule, forming a network of atoms. Like if we talk about graphite and diamond, what is there? There is repetition of carbon atoms, as a result of which we are getting giant molecule, a network solid. So here in the last case, the constituent particles are the atoms and they are bonded by strong covalent bonds. About melting point, they also have high value for melting points. So it's all about the classification of solids. Thank you and have a nice day.